All right, let's go ahead and get started. All right, so again, this is going to be about 30 minutes. The 30-minute presentation, you're going to hear from myself, you're going to hear from Greg Bova, and you're going to hear from Greg Simpson. And again, this is one of 4 webinars. We've already did the first one, which really covered who PureLine was, and then some detailed background on some of the technologies out there. This one, we're going to focus really on the methods for controlling Legionella. Now, this is going to lead up where we get into later strategies for Legionella control. And some of this is going to go beyond the chemicals, whether it's chlorine, monochloramines, copper, silver, chlorine dioxide. We're going to get into all types of things, even down to the level of how you work with your sanitation staff to make sure that you keep Legionella control. And this is more of Greg Bova's background. So, but at this point, so we're going to discuss a selection of best Legionella control chemicals. We're going to provide information on each of those chemicals. We're going to talk about the impact on equipment and piping. We're going to talk, some of this is from studies, some of this is from experience. PureLine has been doing this for 20 some years, and we've seen all types of things. The effectiveness on biofilms, monitoring and controls. Everybody wants to be able to monitor. You really want to understand what you're delivering. Some chemicals are easier to control than others. And then we're going to just touch on a little bit of a boots on the ground thing, Greg Bova at the end, to kind of talk about and kind of round up everything I said and, you know, add a little bit more color to it. So with that, Alex, oh, great, you're ahead of me. All right, the basics. What are the chemicals that are available for Legionella control? Can they be used on both hot and cold systems? And most importantly, are they safe? Are they certified? Are they registered? So if you can see this, and hopefully you can, it's maybe for somebody of my age, my glasses need to get a little thicker sometimes. But here's a comparison of the disinfectants in a hospital environment. Now, Suzanne, I know you're over in Bavaria. I can't say I speak for the EU, but as far as the United States, we see chlorine, we see monochloramine, we see copper silver, and we see chlorine dioxide. Now, those 4 methods make up roughly about 13–14% of all hospitals over 100 beds. What that's telling you is that there's 87% of hospitals that generally choose a wait and see. And for me, being in the industry and have experience when I get clients calling me saying they had a Legionella outbreak and what their hospital went through, it is a very, very tough thing for me to hear when somebody says, well, we've never had an infection, so I'm not going to worry about it. That's like telling, you know, you never hire a safety guy until you have an accident. That just doesn't sit well with me. So let's start with these chemicals. All right. Which ones can be used on cold water? So the chlorine, monochloramines, copper, silver can't, and chlorine dioxide can. Which can be used on the hot water systems? Chlorine, yes. Monochloramine, usually not done. Copper, silver, yes, and chlorine dioxide, yes. The chemical that's utilized is the same above that. Everybody's always interested in the THMs. Am I putting something in my water that can result in some chemicals that are known carcinogens? For chlorine, yes, it can develop THMs. Monochloramines, yes, and those are so related that you can imagine they have the same issue. Copper, silver, no, and chlorine dioxide, no. Environmental health effects. Again, chlorine produces your THM and your HAA5s, as does monochloramines. Copper is an acuity toxic to many species. So sometimes, depending on the hospital, they have issues because you have problems with discharge. And so you have to be very, very careful in that with the copper silver part of it. On chlorine dioxide, it does not generate any of the carcinogens. EPA recognized, again, this is for the United States. So Susanna, just bear with me on this. I don't know the EU, but from the EPA, yes, it is recognized for drinking water as a disinfectant. For chlorine, for monochloramines, yes. For copper silver, no. Okay, it is only recognized by the EPA for Legionella control. And chlorine dioxide, yes, below 0.8 ppm. And guys, if you notice a difference, and I get this question a lot, maybe Dr. Greg Simpson might want to respond here. You'll see chlorine, the EPA registers at 4 ppm and below, but look at chlorine dioxide, it's 0.8. The amount of chlorine dioxide you need for a treatment is anywhere from 14% up to 33% of what you would use in chlorine. Greg, can you give a little color commentation to that and just talk about those differences?
Oh, sure. Yeah, in drinking water in the U.S., for both chlorine and chloramine, you've got a maximum of 4 parts per million. Now, in the U.S., chlorine is sometimes used throughout the whole distribution system, because if you feed 4 parts per million, you can get several parts per million at the end of your distribution system, because it's not very good for biofilm. Monochloramine doesn't, the EPA doesn't allow, I think this is true, does not allow monochloramine, it doesn't give monochloramine any CT credits. Consequently, when monochloramine is used in a potable water application, they have to pre-oxidize with either ozone or chlorine dioxide. The monochloramine is added only to provide a residual that they can measure. Chlorine dioxide at those low levels of 0.8 parts per million typically would not get to the end of the distribution system. Is that kind of what you were interested in?
Yeah, that's exactly what I'm looking for, Greg. Just
I might also point out that chlorine dioxide is the only disinfectant that has had its regulatory limits increased. Before, they allowed 1 part per million of TRC, total residual chlorine, any chlorine species, if you fed chlorine dioxide. When they separated, when they did the toxicity studies and everything like that, and they were able to separate the effects of chloride from the effects of chlorine dioxide, they actually increased the regulatory limits. Now chlorine dioxide can be 0.8 and chloride ion can be 1 part per million. So just a little interesting.
And let me turn a little bit over to Greg Bova here. Greg, at Johns Hopkins, can you talk about THMs and the HAA5s, the 5-pack there? Can you tell us, is that a big concern in the hospital? And also, I think Susanna is asking, she has a HAA5s. Scott provided a definition, but the THM, can you give her the full chemical name so she can look it up?
Yeah, well, since Baltimore gets chlorinated water, we have to measure the H5's THM and report that on a quarterly basis. And so since chlorine dioxide doesn't generate that, and that we are a licensed water treatment facility in the state of Maryland, we have to do this reporting. And so we test the city water levels coming in and what are downstream of chlorine dioxide generation, because we don't want to exceed the EPA limits of the H5s and THMs. And so because chlorine dioxide does not generate H5s, THMs, it's a non-issue. But, we do have concerns, especially, if you use a chlorine monochloramine system and you generate THMs, well, if you're serving a cancer treatment building or something like that, it becomes an issue that you can contaminate your water quality. So, and we do have a cancer treatment building that we treat. We've been treating for 21 years here. And, last thing we want to do is put carcinogens in a water supply that has cancer patients.
And I'm going to pronounce this correctly. Trihalomethanes, THM. Anybody have a, Greg, Dr. Simpson? Trihalomethanes.
Yeah. Well, methane is a carbon with 4 hydrogens, and trihalomethanes are basically methanes, where 3 of the hydrogens have been replaced with typically chlorine, although some brominated trihalomethanes are bad. The reason they call them, I was typing this to the chat channel, but I'll say it instead. When they identified trihalomethanes was the cause of stomach cancers in a lot of the areas of the United States where surface water was treated with chlorine or ozone, they began to correlate the presence of those trihalomethanes, which are bromodichloro, dichlorobromo, and bromoform. So from chloroform to bromoform, which is CHCl3 and CHBr3. Anyway, when they identified that those were causing cancers, the analytical capabilities were not good enough to speciate them. So they lumped them all in together. Now, since that time, it's been found that chloroform is the primary bad THM.
Great. Great. Thanks, Greg. Alex, let's go to the next slide. All right, chemical performance. And again, this is when somebody is buying the hospitals, you know, PureLine, we have many hospitals using our systems. But one of the first questions they ask, whether they're buying a chlorine or a copper silver or a chlorine dioxide machine, are these chemicals safe on my pipes and equipment? Are they safe for my lab? Lab and dialysis is a different thing. When we get to that part of it, I'm going to have Greg Bova talk a little bit about it. And how do they perform on the biofilm? Many of you were not there for the last meeting. Greg Simpson, and you'll see his contact information at the end of this. Dr. Greg has a little video of how chlorine versus chlorine dioxide works on biofilm. And it was work that we did up at Montana State, which is considered the world expert on biofilms. Okay, so first of all, impact on equipment and systems. All right, and the chlorine, potential corrosion and problems. Monochloramine, same. Copper silver, potential plating. So you do hear that conversation about plating on mild steel and localized corrosion. Chlorine dioxide, minimal potential corrosion problems, however, none documented in any of the PureLine hospitals. Now, some of this has to do just with the volume. If we go back, chlorine monochloramines, the EPA, they're using at 4 ppm. We're basically putting out at 0.8 ppm, and that's the maximum most people, most hospitals will treat and try to treat to a residual. So remember, you go in with a dose. So if I dose it, say 0.8 ppm, I'm going to knock that down to 0.5, 0.4 ppm. And I've had some people that even monitor it lower. Greg Bova, what do you guys do at Johns Hopkins? What's your targets on, for example, chlorine dioxide concentration, dose, and residual?
Yeah, okay. Yeah, we at the point of generation where we put in the chlorine dioxide into the water systems, we have to measure that limit, and that's per the state, and that's an EPA requirement. But we maintain around 0.3 to 0.5 ppm. So we get a residual at the end of the distribution system around 0.1 or something like that. So that's a clean system. I know initially we ran it higher during the initial startup where we do a flush of the building system, and we'll go up to 5 parts per million with no drinking, no showering restrictions. But the normal operation is that 0.3 to 0.5 range.
Okay, thank you, Greg. So guys, the next question is, well, how's this impact your very sensitive equipment? In this case, we talked about dialysis because that's the #1 question, followed by laboratory equipment. In many cases, hospitals are doing things in dialysis and laboratory equipment. They don't even want 0.3 ppm chlorine dioxide, chlorine monochloramines. And you'll see here, the chemicals can easily be removed with carbon filters. That's a very, very common approach. So as you're feeding the water to a lab or to a dialysis center, they'll put a carbon filter in line to remove that. What about inhibiting of biofilms? Biofilms, boy, I'll tell you what, it's something you really don't know exists until you do this test at home. So everybody who's online and listening, if you have interest in this, I'll tell you on the side. I went to all my executives and I said, hey guys, the company will pay for a plumber. Let's go put a T where your water comes into your house. Let's just put that T in line, and then we're going to inject it with chlorine dioxide, because you all think you're drinking good, clean water, and let's take a look at what those pipes look like. Well, the newer houses, I mean, the pipes were pretty well clean, but some of the people that had homes that were 25 years old or 20 years old, the amount of stuff that came out of those lines was unbelievable. That was the biofilms that chlorine dioxide was eating up. Now, in this case, though, chlorine and monochloramines are not known to be really biofilm fighters. We couldn't really find anything on copper silver, and when we open up this to the group, if you have any comments on that, we've not been successful finding documentation to show that copper silver is effective on biofilms, but I don't want to state that because I can't find a study one way or the other. And yes, chlorine dioxide, because it is a dissolved gas, is very, very good at destroying biofilms, probably one of the best. And again, breaking down at normal operating levels, information available suggests some biofilm destruction at operational ppm. I would encourage you at the end of this, Greg Simpson does have the little video clips of this, and you can see it. The imaging capabilities at Montana State are unbelievable. And again, still documentation's unknown on copper silver, and on chlorine dioxide, yes, the testing's been conducted. Alex, go back one here. Greg Boba, any comments on the biofilms or anything that you guys run into in your world?
Yeah, well, real quickly on the dialysis and laboratory equipment, there was very little data related to chlorine dioxide and whether or not carbon can remove the chlorine dioxide. And there was some documentation on monochloramines, more on chlorine. And so here at Hopkins, we did extensive testing and found the carbon, the free bed, freeboarding of the carbon, the back flushing that was needed. And, and we found that we've exceeded through 2 carbon tanks, because you needed that 12-minute empty bed contact time in case you had a failure of one tank. You got 12 minutes to disconnect the patient from dialysis before they see that chemicals in the water going to their bloodstream. But we were over 40 treatments equivalent, and the tanks are commonly replaced about 20 treatments. So we doubled the amount of exposure to the carbon, as well as, we're running it, like I said, 0.3 to 0.5 ppm. We're exposing this carbon to like 1 to 2 ppm. So we were really increasing the dosage because we want to make sure that we protect the patients. And as for laboratory equipment, there was a big concern related to staining of slides in our pathology department. So we did testing of our carbon tanks, and we found out they had some issues. And so, overall, that the hospital has a very good, effective filtration of chlorine and the chlorine dioxide now without any issue.
Great. Thank you, Greg. All right, Mr. Alex. All right. And again, I keep telling you, this is an important question. This is the one that everybody really goes after me on. Well, how fast does it work? So it seems to be a key question at hospitals. If I put monochloramines, chlorine dioxide, copper silver, how fast does it work in killing Legionella? So with that, all right, so the contact time, and these are registered by the US EPA, chlorine requires a longer contact time to be effective, which is not available due to domestic water can be utilized within minutes, okay? So basically what they're saying is like, well, yeah, chlorine is effective against Legionella, but you've got to give it enough contact time. So case in point, if you've got a high volume hospital, and I think Greg Boba, we'd be able to count Johns Hopkins as a large, high volume hospital where the water is always moving. But if you have a low volume hospital where the water's not moving very much and you can get the contact time, chlorine could be an option. And then chlorine and monochloramine really fall into the same group. Again, copper silver has never really established that. We do know chlorine dioxide has a very fast CT factor. It all happens within minutes, and we're kind of over engineering that. It really happens in seconds, but we put down 2 minutes, which is plenty of time for it really to be treated and taken care of.
Hey, Bob, I need to add that the EPA CT time is based on 1 hour contact time. And so, you know, does a facility have an hour by the time the water enters and it sits and being treated? It doesn't. Our water, by the time it comes in, it could be 15 minutes or less by the time it comes into our facility. So that's why the quick reacting time was very important to us, because we did not want to rely on the city water exposure in a short period of time, because we did not have an hour of contact time.
Okay, very good. Thanks, Greg. All right, Alex. So which chemical offers the best control performance? Now this is a little bit tricky, guys. We are a chlorine dioxide company, and I'm trying to like portray this on both sides. So I actually called some of our distributors, and they helped me kind of fill this in. So let's talk about monitoring and control. Well, chlorine, yes, there is chlorine monitoring. A lot of it is ORP. Some of it is a chlorine monitor. They're not as accurate as many of my customers would like, but they certainly have this, especially for total chlorine. Greg Boba, before I go off chlorine, do you have any comments on the chlorine monitors that are out there?
Yeah, the basic monitor you have to look at closely for its accuracy. So, you know, they can be accurate and they can be inaccurate. But because we're licensed water treatment facilities, we continuously monitor the chlorine levels as well as the chlorine dioxide.
And does that go for the same, can I use the same comments we just made for monochloramines? Because
Yeah,
really
well, yeah, but the problem with monochloramines, as what's stated up there, is that there's no meter that I'm aware of that you can measure monochloramine levels. So you have to calculate the amount of ammonia to be utilized to come at a ppm that's calculated for the monochloramines. So that is a big issue, and you know, but it is accepted, you know, that the calculation method for control.
Okay, so in that example, what you're saying, Greg Bowen, stop me wrong, you have to really deduce the monitors for monochloramine, deduce what the monochloramine is based off of what the total chlorines is, correct?
Correct.
Okay. All right. Now for copper silver, there's an ionic monitoring. I talked to 2 of my distributors that really push a copper silver. He said the only problem is it's really based off of flow and our pump, because the monitor itself doesn't seem to be accurate enough. And I'd love to hear the Q&A if anybody has a different experience. But what they said was, you know, in comparison to some other monitoring systems, you'd expect copper silver to have something a little bit better. Now, chlorine dioxide, there's several ways of measuring the residual in chlorine dioxide, but we literally, in some of our applications, guys, we use chlorine dioxide in fruit and vegetable wash. We use it in potable water. They use it for Legionella control. We use it in wastewater treatment. We use it in cooling towers. And in some of those applications, especially in the food applications, I've got to get this down to 0.1 or 0.2 ppm. I've got a couple of cooling towers that are so large that they will discharge back to rivers, and they have to make sure there is no chlorine dioxide in that. So they will monitor that right down to 0.1 ppm to keep it as low as possible. Now, this last row here, which talks about remediation, I threw this in there because I didn't have a perfect spot for it, but I want to make you aware of it. So some of our hospitals get in a situation where, okay, they're starting to get some positives for Legionella. They're not getting cases, but they're getting positives. The question is, how do we remediate that? And Greg Bova, I'm gonna let you talk about the chlorine dioxide of what you guys do and I'll come back and talk about chlorine and monochloramines, if that's okay.
Yeah, that's fine. And unfortunately, I got to touch on the basis of chlorine and monochloramines. So if you go to remediate, you got a positive in your water system through your monitoring, or you got a positive patient, you need to remediate. And let's say you're using chlorine or monochloramines. And so if you want to remediate, you got to flood that system with like 50 ppm or 250 ppm. And you're talking about 4 to 12 hours of non-water use. So you fill the water system at the levels of the chemicals, and you've got to close the valves. You can't flush the toilets. You can't take showers. You can't drink the water, and you got to let it sit. Now, Hopkins years ago developed a protocol for chlorine dioxide. And the beauty about that is that you can still flush the toilets, and you can still, drink the water at drinking water ice machines that are filtered, that are designed with carbon to take out oxidants. And so what happens is, and we've done this, we haven't done it in 15 years, but when you remediate, what happens is that you put a notice not to drink the water, not to take a shower, but you can still wash your hands. You can still go to the toilet, because we put a continuous stream of chlorine dioxide in the water system and do a flush, and basically is out with the bad, in with the good. And so, every time we did a remediation, especially in our old buildings until we got them clean, we were negative after we were done. And so we found it to be very effective and minimal disruption to our patients and our operations. If we had to go chlorine, you're talking about bottled water, you're talking about toilet people. We had that, we're cleaning out toilets, bedpans, you name it. So we minimized the interruption by this remediation using chlorine dioxide.
Great, thank you, Greg. And then as far as chlorine and monochloramines goes, it's really kind of the same. You can increase your max limits up to 4 ppm. There's no water restrictions applied during remediation, daily flushing required. Patient water restrictions would be implemented until no detectable Legionella. Now, again, like I said, I apologize. I'm not the expert over in those areas, but I wanted to give Greg's, approach to this. All right, Alex, next slide. All right, so administrative requirements. Susanna from Bavaria, I'm very sorry. This is going to be really about the US side of the requirements. We'll see what more the Germanic issues are later, but let's go ahead. So basically we're looking at what the state EPA requires, okay? Do they require water testing? Do they require a construction and operating permit? Do they require monthly and quarterly testing? And do they require state EPA certified operator license required? Now, some of this varies by state. I'm going to try to give you a fast overview. For operating permits for chlorine, monochloramines, and chlorine dioxide, yes, you have to have operating permits, and that goes for almost every state in the United States. What about water testing? So yes, you have to have water testing. And what you'll find out is a lot of hospitals nowadays, they really want to know that they're covering, and whether they do it with a chlorine or a monochloramine or chlorine dioxide, they want a document that measures accurately and shows that they had a residual amount of the chemical in there so that they're getting Legionella control. Because remember, some patients can come from home with Legionnaire's disease, go to the hospital, and then all of a sudden they say, hey, we got it at the hospital. And then you're out trying to look for it. So hospitals in today's world are asking us that they want very strict monitoring, which is why, like our equipment, and I'm sure some of the monochloramine and chlorine systems do it, we can track down right to every minute, every 5 minutes, every 2 seconds, if you wanted, what that residual was. We then print out a report at the end of the month, and then you do a manual test to show that you manually checked the calibration and proven that out, okay? In terms of monthly and quarterly testing, that varies by state. Again, no information on copper, silver, but the other three certainly need it. An operator license, that depends on the state. About half the states in the United States require an operator license, the other half do not, okay? All right, boots on the ground. Greg, can you add some color commentation to, and Alex, I just put in one simple slide after this, and I'm going a few minutes over, but we'll finish up here real fast.
Yeah,
Greg,
sure.
comments on stuff that we just discussed?
Yeah, so, the following webinars will go into great detail what we've done. So I'm just going to keep it brief. But, over 20 years ago, we looked at the different disinfection methods. And this is chlorine, monochloramines, copper, silver, UV, ozone, chlorine dioxide, superheating. And, so once we narrowed it down to, we wanted something that was very fast reactive, that had a very effective CT factor established by the EPA, that we decided to test chlorine dioxide. And I think us and Geisinger Hospital in PA were the first two hospitals that really looked at using chlorine dioxide. But I know Geisinger did not do the testing that we did here. And because we want to make sure that we had an effective means of control, that we had, which we will talk about later, how do you control the introduction of the chlorine dioxide? But we had to evaluate the dialysis part, the lab part, the corrosion aspects, the biofilm. And so it took us 17 months really to look at, is it really the right path? And so, but that was over 20 years ago, and we're still using it today. So, it was the right path. But, the beauty about being a licensed water treatment facility in the state of Maryland is that if somebody comes here as a patient and they go home and they have chlorine dioxide and they want to sue the hospital, we can say, well, wait a minute, we're a licensed water treatment facility state of Maryland. Here's our monthly reports, here are our quarterly reports, here's our Legionella testing. And next thing you know is, okay, never mind, and they walk away. So a lot of people look on the downside of this regulatory requirement, but it's a blessing in the long run related to legal issues. So I really hope everybody stays tuned for the next two webinars, because we really get into the depth of using chlorine dioxide and how effective it can be.
Yeah, you know what? I actually listened to Greg Bova made a presentation at an association one time, and it was the ideas that seemed so simple once you knew them. As Greg has developed the strategy at Johns Hopkins over decades, just the simple things that he goes, and you need to do this, and you need to do that. I was just amazed, and he had me on the edge of the seat, because there were so many things that, just seemed so simple, yet nobody was doing it, because it took a Johns Hopkins to really study it and kind of, present that out to the world. All right, so with that, Alex, let's go to the next slide. You're going to see Greg Simpson's contact information. If you would like those two videos on the biofilm, you can see my information down there, but let's go ahead and open it for question. Alex, I think you open up the mics, is that correct?
Yes, I can. As part of opening up the mics, what's going to happen is everybody's going to be invited as a panelist. So if you'd like to keep your mic off, you are welcome to keep that muted. If you would like to, share your video, you're allowed to as well. You can also just keep that off. So we're going to go ahead and open that up, though. If you do have a question, then you have the ability to go ahead and share that. So I'm going to go ahead and move that over right now. Everybody should have the ability to talk. If you'd like to ask a question, you are free to unmute yourself, and we can go ahead and have that question. I'm actually going to go ahead and unmute Suzanne. It looks like you might have a question.
Yes, thank you so much, and greetings to all you there. It's a real pleasure to listen to all your webinars, and I'm looking forward to the next ones with more details. What just came across my mind was, you mentioned the private person coming from home carrying Legionella into the hospital. and unknowingly having an impact on the hospital and the water there. Do you offer a machine or application for private homes with chlorine dioxide, so that people who might be afraid living in an old house with old tubing might add it for themselves to be sure to remove the biofilms or not to get Legionella in old tubings, which are seldomly used?
So that's a very good question and a very current topic. So Suzanne, in the state of Indiana, there was a woman back at Christmas who came home from, she was older, you know, in her 60s. I should say she's younger since I'm in my 60s. But she came up from Florida. Her house had been shut down for a while, and then went into home, you know, did like we all did, probably drank some of the water, did whatever she did, ended up with Legionnaire's disease and had multiple, I think she lost 3 of her limbs to amputation, very, very sick. And we've been working on this little program where you're still going to need an outside plumber because somebody's got to plumb it in, but to run the chlorine dioxide through the pipes of a home. And we're trying to build, our goal is to build an awareness that people should be doing this on an annual basis. And it doesn't take much. I mean, the amount that you would need is not much bigger than that little cup right there and pumped into the water system. So anyway, stay tuned on that, but that is a very current topic here.
Hey, Bob, I need to add to that, that if you're a resident and a single household, you don't have to be a licensed water treatment
Correct.
manufacturer and carry a license. So you can do that just because I think it's under 75 people that you're allowed to do a non-permit application.
Great. Well, thanks, Greg. All right. So at this point, are there anybody else have any other questions or would like to ask the panelists, Greg Bova, Greg Simpson, or myself? We're here for you at this point. All right. With that, I think we're going to go ahead and conclude. Everybody's got, you see Greg Simpson's contact information needed or mine. Feel free to contact us. Our next webinar will be in 2 weeks on Tuesday, same time, same channel. Thank you, everybody. We greatly appreciate your participation.